I think our mission for the future is to keep and retain the environmental, let's say, challenges we would have. And I think it's a very good combination of let's get young people, they are still, let's say, in school, having this kind of, let's say, ambition to work together with us as a company. In Europe, still the diesel plays a major role because of the high efficiency of the diesel engine. I have seen a lot of combination here in US within the ChallengeX program where we combine a diesel and a hybrid solution. And I think this is what we can leverage as General Motors over the globe. For me, this is the first event I'm integrated in ChallengeX, and I think it's gorgeous. I mean, if I look into the faces of the young engineers and see this kind of motivation and enthusiasm behind, so this is my takeaway.
ChallengeX is targeted right at what GM is most concerned about as we move forward, and that's fuel economy, CO emissions, and making vehicles more efficient for customers. I mean, what we've seen so far just in the beginnings of the judging today are some incredible concepts. The creativity of the students and the involvement of all of the sponsors is just something that's going to make the world better. We're going to save fuel, we're going to reduce emissions, and we're going to create better products for the customers. What's really impressive is the way that the different technologies are being integrated together. And it's the integration that determines how successful you're going to be. A hybrid technology by itself or a fuel cell technology by itself, while impressive, really don't mean a lot until you begin to integrate them with each other. That's when you get the cumulative gains. That's where the payoff's going to be. The company philosophy has been clearly articulated by our chairman, and that is it's the electrification of the automobile long term. That's where we're going. Now, you have to take small steps to get there. Each of those small steps are huge, huge challenges, huge, huge technical leaps. And it's an activity like this that shows what can be done. The involvement of GM with the university shows the partnerships that result. I mean, it's a win for everybody, but the end point is the electrification of the automobile.
Transportation in Canada is responsible for about 25% of the greenhouse gases. If we can use renewable fuels such as hydrogen from renewable sources, we can eliminate the greenhouse gas emissions as well as the regulated emissions such as NOx, SOx, and the others, ground level ozone, and those emissions that contribute to smog, especially in the urban environments. We support the students in the challenge so we can develop future people working in the alternative fuels area and in fuel cells, hydrogen, and all the clean fuels.
The department feels strongly that we need to help develop the scientists and engineers of the future. And really that's what this competition is all about. We were very excited last year to learn that 75% of the graduating seniors were hired by the automotive industry. That, in our minds, is the biggest success of this program. One of the biggest challenges facing the United States and the world as a whole is energy. It's how we produce it, how we use it, and the greenhouse gases that result from our use of energy. As we go forward, more and more of the world is using more energy. Look at India, look at China. And what we need to do is to be able to use energy more efficiently, produce less greenhouse gas emissions, and be able to maintain the current level of mobility that's critical to our personal and economic well-being. I think we're likely to see examples of all of these technologies and vehicles of the future in different combinations. You see here hybrids, plug-in hybrids, fuel cell vehicles, vehicles that use fuel cells for auxiliary power, and all of these in different combinations are likely to be seen in passenger and commercial vehicles in the future.
Well, one of the goals of my foundation is to try to encourage more women to get involved in the automotive industry. I believe that the more we integrate men and women together, working together, we're going to make better vehicles, and more people are going to buy them, more people are going to enjoy them and operate them. And so when I found out about ChallengeX, that it's this long-term project, it goes from year 1, 2, 3, and now I hear even year 4, and it's teams of college students, university students working together adapting and modifying and changing a vehicle. Well, this is a great grassroots or ground floor of men and women working together, making a vehicle better. And so I wanted to encourage more women to do that, and a way to do that was to create a Women in Engineering Award, and it's been very rewarding. These gals are bright, they're enthusiastic, many of them are team leaders, which is very impressive, and so it's just a perfect marriage between an automotive program, a university, and our foundation to be able to, acknowledge and recognize and encourage more women.
We see ChallengeX as a great opportunity to develop the engineers of the future. Traditionally, engineering disciplines have focused on mechanical, electrical. The cars of the future are going to require cross-disciplinary engineers. ChallengeX is developing those engineers.
One of the things that makes the ChallengeX competition so unique is that we work to establish a level playing field for the evaluation of really several technologies at the same time. And we don't evaluate the results of the competition just on a tank-to-wheels basis where we're looking at the fuel economy in miles per gallon, for instance. We evaluate it on a well-to-wheels basis. And we use a tool from Argonne National Laboratory known as the GREET model to look at the total system impact of the choices the teams have made. So we allow 4 different fuels in the competition. We allow reformulated gasoline, E85, B20, and hydrogen. And then the teams can also choose different propulsion technologies. They can choose hydrogen fuel cells. They can choose various hybridization strategies, whether they're strong or mild hybrids, or they could also choose to do a straight internal combustion engine in some with advanced features added onto it. But they can then take this combination of technologies and work to reduce the overall environmental impact of the vehicle that they've entered in the competition. And it's this becomes a very real world thing, because these are the technologies that in the real world we have to reduce CO2 emissions, to improve specific vehicle fuel efficiency, and so we try and make it as real as possible for the students. From the standpoint of what GM is doing today, the competition has a lot of real world corollaries. Of course, GM is working to advance the biofuel area with particular emphasis on ethanol and E85, and that's of course one of the fuels in the competition. The team that won the competition during the second year, last year, happened to use an E85 flex fuel approach and hybridization. And so that's a combination that we might be interested in looking at in the future. And then of course all the teams in the competition who are using diesel fuel are using B20, which means that it's 20% biodiesel and 80% traditional petroleum-based diesel. Again, a technology that GM is very interested in implementing in the real world. And then of course GM has just introduced its first couple of hybrid vehicles, the GM hybrid system in the Saturn Vue and the Saturn Aura. And this fall we'll introduce the 2-mode hybrid in the full-size Tahoe, which is an even more advanced hybrid system. So you can see how these things dovetail together, and then by combining these technologies we can have either further improvement in efficiency and reduced environmental impact.